All right, this is Ken, and I'm here with Sam, and we're going to go over this. In the last problem we just did, it was nice because the rational zero we found was a whole number, and so it made it very easy. And then when we factored the the quadratic, which resulted, it was also factorable. This one's a little different, and which kind you get is just random. So you might get one that comes out real easy, you might get one that comes out medium hard, or you might get one that's a little more difficult. And it's just random. There's no way to tell. So what I'm going to do here is, since the factors of the negative 3, which is our constant, are plus or minus 1 and plus or minus 3, I'm going to put a 1 and a 3 up top. And since the factors of 7 are 1 or 7, I'm going to put a 1 or a 7 on the side. Excuse me. I just had some Coke and try not to burp into the microphone. Okay, here we go. And then when you take 1 divided by 1, you get 1. When you do 3 divided by 1, you get 3. When you do 1 divided by 7, you get 1/7. And 3 divided by 7, you get 3/7. So these 4 with plus or minus make up the 8 possible zeros of our polynomial, our cubic function that's up there. Are we going to try all of these? We're going to try a few of them because we know that there is at least one rational zero. So one of these has to work because what they told us. How am I going to do that? Well, I'll try the ones first, and if they work, then I'll be happy. I'll try the threes after that. If they work, I'll be happy. I already know the answer because I did this one with a student earlier, but we'll go through the process just the same. So testing the ones. First thing I need is to write 7x cubed plus 13x squared. Actually, let me put it in this. Plus 13x squared plus 19x minus 3. And that is my h of x. So if I want to test if 1 works, I'm going to plug in 1. But because of what we talked about in the last video, we know we just add up the coefficients. Because if you plug in a 1 everywhere for x, you just get back the coefficients. And clearly, a positive plus a positive plus a positive minus 3, it comes out a positive. And if it comes out a positive, it's not a root, right? It has to come out to 0. Plugging in a negative, a negative 1, will change this to a negative 7. 13 will not change because it's with an x squared. 19 will change, but 3 will not. And if I add up a bunch of big negatives and subtract just 13, yeah, Sam is telling me it's negative 16, but the fact is if it comes out negative, it's not a root. Okay, it's not a 0. Up here, this came out to, let's see, 13 kills that, makes it a 10, 29, 36. So I got a positive here, I got a negative there. You know what this tells me? This being a plus and that being a minus? That a root does occur between 1 and negative 1. So there's got to be a root between 1 and negative 1. Well, there's 4 possible roots between 1 and negative 1. So I'm still not going to do that. I'm going to try out the 3's. To try out the 3's, let me switch back to big view. I'm going to do a bisynthetic division. Plug in a 3, 7, 13, 19, negative 3. And right away I can tell you there's no way, because I've done these for a while, that this will work. Because once you start going and adding, 7 times 3 is going to be 21. When I add that on, it's just going to keep getting bigger and bigger. 34 times 3, 102. And then add that, 121, right? And then 121 times, it's just a really huge number. So 3 is definitely not going to work. Let's try negative 3. 7, 13, 19, and negative 3. I might have a chance here. We'll see. Bring down the 7. 7 times negative 3 is negative 21. Negative 21 plus 13 is negative 8. Negative 8 times negative 3, positive 24. 19 plus 24, 43. 43 times negative 3 is way too big for us to get a 0 here, right? 43 times negative 3, 129, negative 129, added up, negative 132. Now, hopefully I didn't make any mistakes there, but it looks to me like 1, negative 1, 3, and negative 3. None of them work. So unfortunately, that means we have to go to the next factor on our list. The next factor on our list is 1/7. All right. Actually, let me do this. I'm going to go to a new page. So if we put 1/7 in the box, and then we put the other coefficient, 7, 13, 19, and negative 3. 7, 13, 19, and negative 3 out here, we check it, we do synthetic division in exactly the same way. We bring down the 7. This number that goes here is 7 times 1/7. 7 times 1/7 is 1. 13 plus 1 is 14. I really like that as 14 because 14 times 1/7 is a 2. 2 plus 19 is 21. 1/7 of 21 is 3. Gives me a 0. So is 1/7 a root? Absolutely. 1/7 is a root. So 1/7, if x equals 1/7, then 7x equals 1. Then 7x minus 1 was my factor. This was my factor. Not that they asked for it in this problem. They just asked to find the roots. So we have the root, but I like to know that. Down here, we have 7, 14, and 21. 7x squared minus 14x minus, or why'd I put minus? Plus 21 equals 0. Why? Because this is our other factor. If this is a factor, or if this is a root, this was the factor, and this was the other factor. Okay, now I have to divide. You see how they have a common factor here? It's all divisible by 7. That'll often happen. So just take out the 7s, factor it out. You get x squared plus 2x plus 3 equals 0. Is that factorable? Are there two factors of 3 that add up to 2? No. You'll have to do this one by quadratic formula or completing the square. So a equals 1, b equals 2, c equals 3, and the quadratic formula says x equals negative b, the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Opposite of b is negative 2. B squared, 2 squared is 4, minus 4 times 1 times 3. It's going to be a 12 all over 2 times 1, which is 2. So negative 2 plus or minus 4 minus 12 over 2. Negative 2 plus or minus negative 8 all over 2. 8. Negative 8 is equal to 4 times 2 times negative 1. If I square root this then I can write this. The square root of 4 is 2. The square root of 2 I can't do anything with. And the square root of negative 1 is I. So I get that all over 2. Distribute the division. I get those 2's cancel. And that's 2 answers. Negative 1 plus the square root of 2i and negative 1 minus the square root of 2i. Remember, complex answers always occur in conjugate pairs. These two are conjugates because these signs are opposite, plus, minus. So what are my roots? 1/7, negative 1 plus square root of 2i, and negative 1 minus square root of 2i. So that's a little harder than the last one we did on the last video, but the process is still the same. You still do, you test using You test the ones out by substitution. You test everything else out by synthetic division. And once you get a root, the quotient of the quadratic, or this quadratic quotient is right there. You write that, and you factor or use quadratic formula on that to get your other two. The good thing is on this problem, they'll never give you something with a degree higher than 3. So if you find one, it'll automatically reduce to a quadratic, and the quadratic can be factored, or you can use the formula on it. Yeah, praise God. Okay, so that's it.